Hello everyone, welcome to the sixth part of the video tutorial series Learning Pandas from Zero. My name is Shing Chile, and in this tutorial I will be your guide in Pandas. Today we will explore together how to process data in a data frame in the column level. In this chapter, we will focus on numerical data. We will discuss operation on textual data in the next chapter. Let's recapitulate what we have learned in our last tutorial. We have covered how to describe a data frame based on its structure and statistics. Namely, we have learned how to extract the rows and column headers, data type and properties of the unique elements along each column, and finally the basic statistics, such as average, standard deviation, quadrantile, and so on in a data frame. We have introduced a number of attributes and methods in the last chapter, so I encourage you to review the chapter if you are not fully familiar with those commands. Now we will do something more. In this chapter, we will introduce two concepts. First, we will demonstrate how to use condition to filter the data frame so that you collect rows which satisfy the condition. Second, we will learn how to operate the data collectively in the column level. We will learn how to apply the algebraic manipulation and self-defined method to the column data in order to modify the data or to create a new column based on the original data. First, let's talk about the data query. This is a very common procedure when we use the relational database such as MySQL or PostgreSQL. By providing the conditions to the data frame, you will obtain the subset of the database where each of the entries satisfy all the conditions you have provided. Pandas has something very similar in the syntax. We can use the format, data frame, square bracket, and inside the square bracket, you put in your condition. For example, if we write df square bracket df apple greater than 10, this means we are asking Pandas to return us the subset of the data frame where the value in the apple column is greater than 10. Notice that we need to write twice the name of the data frame in this type of query. The first one corresponds to the data frame we want Pandas to return, and the second one corresponds to the condition Pandas needs to consider. Let's take a look at the simple example. In the left example, we input one condition, which is the column orange being less than 30. If we look at the original data frame, indeed, two rows, namely row 1 or shop 1 and row 2 or shop 2, satisfy the condition. Pandas return us a new data frame which contains these two rows only, and this satisfies our expectation. In case we need Pandas to match a set of selected values, we can use the method isIn. Then you pass the iterable or list, which contains the set of values Pandas needs to match. In the right example, we ask Pandas to return a new data frame where the value of column apple equals to 18 or 21, and exactly to what we have expected. By looking at the original data frame, the returned data frame contains the two rows we need. When we have multiple conditions for Pandas to match, we can align them side by side and connect them with the logical operator AND or OR. Notice that we need to use bracket to enclose each of the conditions. Otherwise, Pandas will raise an error. In the example shown here, we provided two conditions to Pandas. The first one being the column orange being less than 30, and the second one being the column apple being greater than 20. If we take a look at the original data frame df, we find that shop 2 satisfies both conditions. And indeed, Pandas returns us a data frame with only one row. Now let's try to see if you have mastered the query skills. Your dear friend comes to you again. This time your friend only gives you the header of the data frame, which contains the staffs in the shop and the fruits they have sold. Your friend asks if you can provide the code to do the following queries. Can you help your friend? This time there are 3 tasks. So feel free to pause the video and try to see if you can think the answer. Let's check the solution. First, we need to get the data frame where the staffs sell more than 10 apples. Then we just need to do the standard query, df square bracket df column apple greater than 10. Remember, we need both df because we are doing a query instead of asking Pandas to return a series of Boolean. Second, we try to get the number of staffs whose ages are between 20 to 30. So we need to use composite conditions. One is for above and equal to 20, and the other is for below and equals to 30. Then we use the link method to find the number of entries. Finally, we need to use both composite conditions and the method isIn. Notice that we cannot use greater than or less than. Instead of one isIn method, you can also separate the conditions into two OR conditions. This means the age either equals to 25 or 30. So feel free to choose either one to achieve your query. Now we have finished studying how to query the data frame to get its subset. We now proceed to discuss how we can change the data collectively. For individual data modification, we have covered it in Chapter 4. But that is not an efficient method if we have thousands of rows of data waiting to be changed. In that case, we need to pass an automated prescription to Pandas and ask Pandas to change them once and for all. Pandas has some default built-in methods such as add, sub, mult, and diff, which is equivalent to addition, subtraction, multiplication, and division. By using these, we can add, subtract, multiply, and define all data along the same column with the number we need. We can also treat the whole column as a single integer or floating point variable. As shown in the example below, we can simply type df orange plus equal 1, then it means all the data along the column orange will be added by 1. We can also operate multiple columns by using the list notation we have introduced in Chapter 3. Then Pandas will apply the operation to all columns you provided. When we want to do column-specific operation, then we can pass a list of values instead of a single value. As shown in the bottom right example, we can pass the list containing two elements, 2 and 3, and Pandas will match it automatically to the operation along column apple and orange, and add 2 and 3 accordingly. Another way to modify the column is by column manipulation and by the method apply. The column manipulation allows you to treat the whole column as a single variable, and we do arithmetic based on these variables. In example 1, we try to create a column sum by defining it to be the sum of columns apples, oranges, and kiwis. And when we look at the result, indeed, the column sum corresponds to the sum of values of the original 3 columns. In example 2, we introduce the method apply. This method takes the method or function name as an argument. Pandas then pass the entries one by one to this method and get its returns value. Here we show an example where we create a new column called apple2, which is based on column apple but adding 1 by value. We also defined the method add1, which simply returns the value added by 1 from its input argument. When we check the result, indeed now there is a new column called apple2, whose value is 1 greater than that of column apple. I remark that this applies only to a method with a single argument. In the previous slide, the method apply allows you to pass only one column to a method. So what should we do if we want to pass multiple arguments, similar to what we have done to combine the column apple, orange, and kiwi to form a new column sum? There are 2 ways to achieve that. First, instead of selecting a particular column and use the method apply, we can use the method apply to the entire data frame. In that case, Pandas will pass the entire row in each iteration to the method. Then we can select the necessary row or column in the method. Another method is done by using the lambda method as an intermediate. This means that in the method apply, we further plug in a lambda function, and the lambda function calls the method which requires multiple columns data. This can bypass the single argument limit of the method apply because in the view of the method apply, there is only a single argument being passed, which is the row. Let's look at one example. Here we define a new method called newSum, which takes three numbers, value 0, value 1, and value 2. And this method returns a result based on some algebraic operation on these three values. And to pass these three values to this method through the method apply, we define a lambda function. This function takes in the row, which is exactly what Pandas will pass in each iteration to our defined method newSum, but with the corresponding data specified. Here we define access equals 1 because we are operating along the same row. If we want, for example, the sum of apples in all shops, then we set access equals 0. Finally, let's take a quick look at two more methods. When we want to change the parcel column or a data frame, this can happen very often. For example, we only want to change the data of some members based on their attributes. Pandas has two distinctive methods. The first one is mask, and the second one is where. They are basically identical concepts, except that they apply to the rows which satisfy or do not satisfy to the condition respectively. In this example, we operate the data frame with the mask method, which means the operation acting on rows which satisfy the condition. The condition we set is that the column apple being less than 25. If that is the case, we change its value to 20. If we look at the original data frame, shop 1 and shop 2 satisfy this condition, and indeed on the output data frame, we can see the apple column being changed to 20 in the first two rows. Finally, let us exercise again to see if you have learned well today's new material. Your friend comes to you and asks for your help. Can you help your friend with the Pandas script for the following tasks? Again, feel free to pause the video if you need some time to work on the solution. This time you need to help your friend to process the revenue report of the company which record the staffs, their age, and how many apples they have sold. Let's take a look at their solution. First, we want to find the data frame where the staff's age is between 20 and 30. If you have done the previous exercise, this one should have no difficulty for you. We just need to use the composite condition and pass it like an index of the data frame. Then your friend needs to correct all the ages of all staffs because the year is wrong by 1. Remember, there is a column operation available in Pandas, so we just need to treat the columns as a single variable and add 1. Then Pandas will add 1 to all entries along that column. For the third question, we try to get the new column called total. To do so, we simply treat the column as a variable and do the multiplication directly. That's easy, right? Finally, we want to change all prices of apple to 1 when its value is less than 1. To do so, we need to use the mask method. Pandas use the mask method to filter entries whose apple price is less than 1. Then we set it to 1 accordingly. Remember, we need to set in place equals true to keep the changes. So that's the end of our 6th tutorial video. And once again, thank you for watching this video. I hope to see you again in the next tutorial. We will learn how to use Pandas to process column data collectively for our text analysis. Again, practice makes perfect. I will encourage you to also read my open source ebook to do some of the related exercise to strengthen your skills. I hope you have enjoyed the tutorial today. See you.